Hello all, welcome back to the video series of real analysis on Ganitha Shastram. In this video lecture, we are going to learn about bounds of a sequence, supremum and infimum of a sequence. Bounds of a sequence. In view of bounds, sequences are of two types, bounded sequence and unbounded sequence. A sequence is said to be bounded sequence if it is bounded above as well as bounded below. And a sequence is said to be an unbounded sequence if it is either unbounded above or unbounded below. Now, let us look at bounded above sequence. A sequence Sn is said to be bounded above if there exists a real number k such that Sn is less than or equals to k for all n belongs to the set of natural numbers, and the value k is called an upper bound of the sequence Sn. Example, sequence 1 by n is defined as 1, 1 by 2, 1 by 3, 1 by 4 and so on. This sequence is a bounded above sequence since all the terms of the sequence is less than or equals to 1 and the upper bound is 1. Bounded below sequence. A sequence Sn is said to be bounded below if there exists a real number k such that k is less than or equals to Sn for all n belongs to the set of natural numbers, and k is called a lower bound of the sequence Sn. Examples. First one. Sequence n square is defined as 1, 4, 9, 16 and so on. And this sequence is a bounded below sequence since all the terms of the sequence is greater than or equals to 1 and the lower bound is 1. Second example. Sequence 1 by n is defined as 1, 1 by 2, 1 by 3, 1 by 4 and so on. This sequence is also a bounded below sequence since 1 by n is greater than 0 for all n belongs to the set of natural number and the lower bound is 0. Bounded sequence. A sequence Sn is said to be bounded if there exist two real numbers small k and capital K such that small k less than or equals to Sn less than or equals to capital K for all n belongs to the set of natural numbers, which means all the terms of the sequence have to lie between two real numbers. Or a sequence Sn is said to be bounded if there exists a real number L such that absolute value of Sn is less than or equals to L for all n belongs to the set of natural numbers. That is, the range of the sequence is bounded. Examples. First one. Sequence 1 by n is defined as 1, 1 by 2, 1 by 3 and so on is bounded since all the terms of this sequence lies between 0 and 1. Second example. Sequence minus 1 whole to the power of n whole divided by n is defined as minus 1, 1 by 2, minus 1 by 3, 1 by 4 and so on is bounded since all the terms lie between minus 1 and 1. That is, absolute value of minus 1 whole to the power of n divided by n is less than or equals to 1 for all n belongs to the set of natural numbers. So, it is bounded. Unbounded above sequence. A sequence Sn is said to be unbounded above if it is not bounded above. That is, if for every real number k there exists m belongs to the set of natural numbers such that Sm is greater than k, which means for every real number there exists another real number in the sequence which is greater than the chosen real number. Unbounded above sequence has no upper bounds. Examples. Sequence n square is defined as 1, 4, 9, 16 and so on is an unbounded sequence and it has no upper bound. Unbounded below sequence. A sequence Sn is said to be unbounded below if it is not bounded below. That is, if for every real number k, there exists a natural number m such that Sm is less than k. Which means, what small we choose a real number, there exists another real number in the sequence. Unbounded below sequence has no lower bounds. Examples. Sequence minus n is defined as -1, -2, -3 and so on is an unbounded below sequence and it has no lower bound. Unbounded sequence. A sequence is said to be unbounded if it is not bounded, or a sequence is said to be unbounded if it is either unbounded above or unbounded below. Examples. Sequence -1 whole to the power of n into n is defined as -1, 2, -3, 4 and so on is an unbounded sequence. It has no upper bound and no lower bound. Supremum of a sequence, or it can also be called as least upper bound of a sequence, and it is defined as the least member m if it exists of the set of upper bounds of the sequence Sn is called the least upper bound or supremum of the sequence Sn. More clearly, if a sequence Sn is bounded above, then there exists an upper bound. There are more than one upper bound. So, the least member of all the upper bounds is called as supremum of the sequence. Example. 1 is the upper bound of the sequence 1 by n. So, the real numbers greater than or equals to 1 are all upper bounds of the sequence 1 by n. 1 is the least member out of all upper bounds. So, supremum of the sequence 1 over n is 1. Infimum of a sequence, or greatest lower bound of the sequence, is defined as the greatest number m if it exists of the set of all lower bounds of the sequence Sn is called the greatest lower bound or the infimum of the sequence Sn. Which means, if a sequence Sn is bounded below, then there exists a lower bound. And we know that there are more than one lower bound. So, the greatest member of the set of all lower bounds of a bounded below sequence is called the infimum of the sequence. Example. 0 is the lower bound of the sequence 1 by n. So, the real numbers less than or equals to 0 are all lower bounds of the sequence 1 by n. Here, 0 is the greatest number out of all lower bounds. So, infimum of the sequence 1 over n is 0.